Welcome back everybody, and in this video we're going to be taking a look at EIGRP with VRF Lite. Now, EIGRP with VRF Lite is almost identical to the way we did it with RIP in the previous video, with a couple of small twerks, other than the fact that we have to configure EIGRP instead of RIP. We're going to go ahead and take a look at this on our topology. Same routers we were working with as before, and we're going to go ahead and get this configured here and operational. So on R5, all we're going to do is we're going to enable the commands and it's for IPv4 first, and then we'll do IPv6. Now, because of the fact that we're doing IPv6 VRF Lite, we're going to be using named mode. Now, if you've never dealt with named mode before, that's okay. We're going to be taking a look at this as we go along. So, fast forward to the EIGRP section if you don't know what you're looking at here or you don't understand the syntax. We are going to take a deep dive in name mode down here. It's going to be all named mode down there. So, first and foremost, we're going to go to global config and we're typing router EIGRP, and then you either give it an autonomous system number or a name. So I'm going to give it CCNP, question mark, hit the enter key. And then under here we type in the address family. It's going to be IPv4. We're going to specify that it's going to be VRF dynamic. And we go underneath here and we say autonomous system, and we say, in this particular case, I'm going to use autonomous system 100. Now we're underneath the AF mode. Now under here, all I have to do is type in network and then network IP address. In this case here is going to be 10.0.0.0, and I'm going to specify that I use 0.0.255.255.255 because I don't want to get specific with IPs. I just want to enable on any interface that's in this VRF that's got an IP address starting with 10. I hit the enter key, and I also want to do network of 192.168.0.0, 0.0.255.255. Now the wildcard mask is which is what this guy is right here. This is the opposite of a subnet mask. Where a subnet mask is, if we were just to go here and specify that 255.255.0.0, and this one here, this is the wildcard mask. This is the subnet mask. If we were to do a wildcard mask on this guy, it would be for the one above it. So the 0.255.255.255 is basically saying 255.0.0.0. That's what it's saying. So I'm saying if it starts with 10, go ahead and enable it. This one says if it starts with 192.168, go ahead and enable it. That's all that means. And I'm going to cover that in EIGRP when we get there. Same thing with RIP doesn't take that into consideration, so we won't have to worry about that. We're going to go on router 3 and do the exact same thing. We're going to exit out and type in router EIGRP CCNP. Type in address family IPv4 VRF dynamic, and we're going to specify the autonomous system of 100. I'm going to type in network.10.0.0.0, 0.255.255.255, and that'll get us an EIGRP adjacency with R5, as you can see. And we're going to do the exact same thing on router 1, router EIGRP CCNP, address family IPv4 VRF dynamic, and we're going to specify autonomous system 100. Network of 10.0.0.0, 0.255.255.255, and then a network of 192.168.0.0, 0.0.255.255, hit the enter key. So now, what will end up happening is if I go back to R5 and I do a do show IP route VRF dynamic, I should have two EIGRP routes in the routing table. The first which is going to be the connected network, and the second one is going to be R1's loopback. So if I wanted to ping R1's loopback from R5, do ping VRF dynamic 192.168.1.1 sourcing off of loopback 10. That is exactly what I would expect to see. And that is IPv4 running this. Now it's actually kind of cool, and I'll show you what this looks like here in just a moment, is when you want to do this for IPv6, it's even simpler. As long as the IPv6 interfaces are turned on, which means they're no shut and they're up, all we literally have to do is type in address family IPv6 VRF dynamic autonomous system 100. That is it. Now we have to go over to the other routers on R3, exit out, and I'm going to go ahead, right click and paste. That's an EIGRP adjacency with R5. And on R1, exit out once, right click and paste. That's all I have to do. Now if I go back to R5 and I go in here and instead of doing a show IP route for this one, I'll do a show IPv6 route. Guess what I have in the routing table? I have R1's loopback already. So I'm going to do a do ping VRF dynamic of FC00:1, sourcing off of FC00:5 all day long. I can reach it. And that is how the IPv6 VRF aware process works. It works the same way if you're not in a VRF. You just have to enable the address family and it automatically starts forming adjacencies. It's very, very easy to work with. And you'll see that when we get into the EIGRP. So that's pretty much all we're doing. So what it did here, it says packet sent with a source address of FC00:5 %sign dynamic, meaning that this address is located inside of the dynamic VRF, and that is a source address, which means that this ping was sent from that VRF. Pretty simple stuff. That's really it. So we're going to go ahead and do verification now and do a show EIGRP address family IPv6. Well, let's do IPv4 first. IPv4 VRF dynamic question mark. We're going to type in neighbors. And this is our address family for IPv4. We have an adjacency with router 3. And if we look in here, we do interfaces and we hit the enter key. We have our interface. We have one peering on fast Ethernet 0/0.20. All looks good there. We're going to do now, go back up to the top here and do V6. That is our V6 adjacency. Now, the one thing I don't like about the way the V6 adjacencies come up is unless you have gone underneath the interface and you have specified a IPv6 address that you can recognize, you get this output, which is the MAC address of the interface. You get the second bit flipped, so it's unique local, so that it has been changed. The 7th most significant bit in the header is flipped to be a 0 or to be a 1, which means it turns into a 2, and then they go and they add this FFFE because the MAC address by default is only 48 bits. You need to have it go to 60 or it's 48 bits. The IPv6 address has to be 64 bits. So you have to add padding, which is what this FFFE is in the middle here. So that's going to be basically how you would correlate that. So if we take a look at that, we did the neighbors. We're going to go down and do the interfaces. We're going to do the IPv6 as well. And we have one adjacency there. So that's pretty much how you would verify EIGRP as well. Now there is a non-IPv6 address family too. If we do a show IP EIGRP, the problem with this output is it's going to be for IPv4 only. I like this command right here because it's address family agnostic until you give a specific address family to look at. This is the way that as you get into BGP and you start dealing with a dual stack environment where you're running IPv4 and IPv6 at the exact same time, this is where that would come into play. Very, very important that you understand that, and we'll take a look at exactly how that works as we move forward. Beyond that, guys, that's pretty much it for laying out EIGRP with VRF Lite. I hope you enjoyed it, and catch you guys in the next video.